morning, good afternoon, and good evening, wherever you may be. Welcome to the Spring Webinar Program. My name is Peter Humphrey, as always, your host. And I am very fortunate today to be joined by long-time Spring team member, Arjen, who we haven't heard from in a little while and has come to us today with some really cool stuff to kick off. Kind of a launch series here for Spring Framework 5 with all the new and interesting things that are happening on the reactive front. So Arjen, would you introduce yourself to people that might not have heard from you in a little while, and tell us what you want to talk about today?
Sure. Hi, my name is Arjen Poutsma. I have been working for Interface 21, Spring Source, and Pivotal now for about 12 years. And today I'm going to be talking about a new feature of the Spring 5, namely the functional web framework. So I'm going to share my presentation. All right. Okay. So, new in Spring 5, functional web framework. This is about me. Most recently, like I said, I worked on Spring 5. We've been doing that together with Lawson and Sebastian, Brian, and others for almost 2 years now. And now, finally, we're seeing the general availability of Spring 5. And we're very excited about that. So I'm going to say a couple of things about annotations. And they are not positive. So I wanted to make sure that you understand that I don't dislike annotations. I do like annotations. In a matter of fact, you can see right here that the original controller interface or controller annotation actually has my author tag on it. But like I said, there are some downsides. Basically, these are things that we experienced and you experienced as well when dealing annotations in frameworks. One particular thing is the so-called magic, right? When using annotations, the issue with annotations in Java is that they only contain data. They do not contain any behavior like regular objects. So any kind of behavior that you want to add or want to customize basically has to be contained in a completely different API. So you have to imagine that you have your annotations on one side with all the data, things like request mapping, things like add controller, all those kind of annotations. And on the other side, you have the Spring code, the framework code that interprets these annotations, right? That's sort of the behavior. Now, if you want to override that behavior, that's certainly possible, but the point remains is that you have to use a completely different API, a completely different piece of the framework to customize that. I always say that you cannot put a breakpoint on an annotation, right? So you cannot really step into in an annotations, or at least the annotations behavior in your debugger. So that's one particular downside. The other thing is reflection, right? Typically, if you're using annotations, then you have to use reflection in order to get them. And that also has a little bit of a performance downside, and more importantly, perhaps, you have the downside of type erasure. So when we came up with doing this framework, basically we had a couple of goals. One important goal was saying, okay, in Java 8, we have a lot of new capabilities. We have, of course, lambdas, very important, functional interfaces, and we have a couple of APIs built around those, namely Java util function and Java util stream. These APIs, these packages, basically contain a new sort of different functional style way of working. Specifically, most importantly, the stream package, right? For those of you who have used Java util stream, you'll know that you typically deal with streams in terms of mapping, having predicates, using all kinds of anonymous or lambdas, basically, functions. And what we tried to do is saying, okay, let's take that approach and see if we can make a web framework with it. Another goal that we had was saying, okay, let's focus more on being a library and less perhaps being a framework. So what that means is that we want to be a bit more explicit. Everything that happens is basically a result of an action or a piece of code that you wrote, or something that's at least very clear where the behavior comes from. But it also means that it's because of that, it's more customizable, easier customizable at least, because you can just look at the existing code and add your own code to it. So let's dig a little bit into functional programming within the scope of Java 8. I don't want to talk about pure functional programming in other languages like Haskell, all that kind of stuff. I just want to focus on our pragmatic stuff that we have in Java 8. So one very important piece of functional programming is a concept called immutability. And what that basically comes down to is that if you have an object, you construct an object with a constructor, it doesn't change afterwards anymore. There's no way to change the internals of that object. So that basically typically means no setters, right? Just construction arguments. Might also mean using immutable collections instead of mutable collections. So what that typically means is if you have immutable objects, you want to change them though, so you end up with a lot of builders. And if you look in the GDK, there's a couple of examples there, right? String builder is obviously the prime example there. The string itself is immutable. String builder obviously isn't. You can append things to it. You can prepend stuff to it. And with the fact is with immutable objects, you basically get thread safety for free, right? Because there's no way to change the object. You can use it in a lot of threads at the same time. Another key aspect of functional programming is first-class functions. And that basically means using functions as first-class citizens, so as method arguments or as return values. And the assumption there is that you can reuse the same method but with different kinds of behavior. So let's again try to give you an example with string. In string, currently you have index of car, right? You find the index of a particular character within a string. And that's very useful for finding, once again, that particular character, but it's not very useful, for instance, to find the first capital letter that's part of the string, or the first space, or any kind of the first white space, right? These are not expressible in a single car, but it would be nice to be able to have an index of method, which does allow you to do that. And that's where that predicate version comes in. That's on the bottom right of my slide. Imagine that imagine that string would contain an index of method that takes a predicate, that's from Java util function once again, predicate of a car, then we would be able to say, okay, give me the index of the first character that facilitates or that applies to this particular predicate. Right? So you end up with a lot more flexible code as a consequence. The final piece of functional programming that I want to talk about is pure functions. And basically the idea there is that you have a function, you give it the same arguments, it should end up with the same result. Ideally, your function should not have any side effects. However, if you don't have any side effects, your program will not do a lot. Right? You will not be able to print anything on the screen. You will not be able to read anything from a file or from a database, because those are all side effects, traditionally known as side effects. So what you typically want to do is put those side effects on your application boundaries, like at the front of your application, at the end of your application. But in between those layers, you want to have be as pure as possible. So be as stateless as possible. Don't really use any external data that's not coming from the arguments. As a consequence, if you have pure functions, you'll end up with code that's a lot easier to test. And I'll show you that later when I start doing my demo, but it's a lot easier to test. It's also a lot easier to cache. You know that the result is always the same, given the same arguments, so you might as well cache them. And if the results are independent of each other, you can also easily parallelize them. Right? You can say, well, I'm going to run this particular code on this thread and this particular other code on this other thread. So those are basically the functional concepts that we want to focus on when we built that we wanted to focus on when building this new web framework. If you look at the complete picture, you'll see that in Spring 5 we have on the left-hand side we have the more traditional web MVC with the servlet API below that. That's Spring MVC as you know and love it, with controller and request mapping. Now in Spring 5 we added two whole new layers for that. We have basically what we call reactive HTTP, which is sort of comparable to what the servlet API does in synchronous world, but then with support for servlet 3.1, Netty, Undertow, and of course Reactor. And on top of that, we have, it's wrongly shown in this slide as Web Reactive, it should be Web Flux. We basically have Spring Web Flux, which is a sort of comparable layer as Web MVC. Right? That's where we interpret annotations, that where we deal with converting your body into JSON or reading a request body from JSON into an object that you can use. And nowadays we have basically two APIs sitting on top of that as well. So on the one hand we have controller, request mapping, REST controller, all the annotations that you know and love. Right? These are essentially, well, they are exactly the same. Whether you use them on Web MVC or on the reactive stack, on the Web Flux. And on the right-hand side, we now have a new API, and that's just basically the router function web framework. And that's going to be the topic of my presentation today. So, and I'm going to switch over to my IDE, and I'm basically going to be creating this whole framework or showing you how it's built, just one piece at a time. So I'm starting from scratch. So hang on a minute when I switch over to my IntelliJ. So I have to share it. I'm doing that now. All right. I think that shows nicely. Yeah. All right. Let's also open my script here on the right-hand side. Okay. So what do I have here? I have a demo class, which is not that interesting. I have a very simple domain. I have a person. That's just a Pojo with a name and an age, and some additional Jackson properties that allow you to specify these as constructor arguments. I have a repository for that. And this is more or less the way you would expect a repository to look when dealing with reactive data stores. So for those of you who've looked into Spring Reactive or Spring Web Flux a bit further, know that we depend quite heavily these days on a thing called Reactor, a project called Reactor, also run by Pivotal. And in Reactor, there are two main data types, namely mono and flux. Mono represents a stream of objects, a stream consisting of 0 or 1 object. So it's either something, in this case a person, or it's not a person. But it's important to know that this stream is asynchronous, right? We don't know, it's not a list, it's not an array, it's not a vector. It's a stream of persons that will, and that will be, when requested, will be pushed to you at some point in the future. So mono, basically 0 or 1 person in this case. Flux represents a stream of 0 or more. Right? So flux is just an open-ended stream, in this case of person. So when you look at it that way, the signatures here make a lot of sense. So we have get person given a particular ID, then we return a mono, a future, more or less, person with that particular ID. When you're calling all people, you'll get basically a flux of people. So the entire flux consists of all people that we find in this particular database. The next method is to save a person. So once again, we're using mono. We're saying, well, when you want to save a person, the person might be coming from an asynchronous data source. So let's allow for a mono person basically here. And let's also return a mono void. So rather than returning a plain void, we're going to return a mono void. And that might look a bit strange, but the basic idea is that we're using here mono not necessarily as a stream of elements, but more as a completion signal. So we're saying this mono, this stream, will complete when the save operation is complete. That's more or less what that is expressing. So once again, you can look at that also as just a future. So we have this. I could have used the Spring Data to create me a Mongo implementation of this. However, for this particular demo, I tried to, or I created a very simple dummy repository that doesn't really do anything useful. It stores everything in a map, as you can see. But at least the contracts are still there too. So the fact that we're using a dummy here is not that important. Know that you can use Spring Data to create a really nice reactive repository as well. Okay, so that's that. That's basically the domain that I want to expose. And basically what I want to end up with is something very similar to this. So this is a traditional annotation-based controller that's exposing the repository that I just showed you. So nothing revolutionary about this, right? We have a REST controller with a get mapping. We're returning a flux of all people. We have a post mapping with a particular consumes condition saying, okay, if the posted stuff is JSON, then we want to have that as a person mono. This is also what Flux, by the way. This is just the annotation-based version of the Flux. And finally, we have the get person where we want to use some sort of path variable ID, and we want to pass it on here and use that to get a particular person from the repository. So this is what I want to achieve, but now with the functional web framework. So I'm going to cheat a little bit. I'm going to use a couple of classes that are coming, basically taken as is. So I'm going to use something called server request, and I'm going to use something called server response as well. And basically, as you would expect, these represent request and a response in a functional way, right? They're part of the functional package. What does that mean? Well, for one thing, they're immutable. So there's no way to change the request as it comes in. You can create a new request. You can copy an existing request and change it in a way, but you cannot change an existing request. We'll be using this later, so I won't be going into these too much now, but know that also there's a server response, which also contains the things that you would expect, right? The status code, some headers, some static methods to create new ones, etc., etc. I'll be using those in a second, so I will be needing to show them very deeply. So yeah, let's get started. Let's create our own web framework, right? I've looked a lot at Josh's presentations. He's always starting from scratch, so I figured I do that as well. Instead, however, I'm going to build a framework instead of an application. So I'm going to build my own little handler function framework or a functional web framework to show you how all the pieces fit together. And at some point, I'm going to say, this is pretty much what's in Spring 5, except that I've now built it myself, and we can easily switch to the provided version. So let's start. Starting point will be an interface we will call handler function. So handler function is essentially what's the thing that's going to resolve the request, right? It's going to take a request, server request, which I just showed you, and is just going to return a response or do something with that into the response. So you might think, okay, let's take a look at some inspiration here. Let's use the servlet signature. Right? So then we'll end up with something like this. Right? This is pretty much, it's not exactly the same, but it's pretty much what the typical servlet also takes. You take the request and you get the response as well, so you can start writing to it. That said, remember what I earlier in my slide deck, I showed you the principles of functional programming. This is not a side effect-free function, right? This function as a void return type. So that basically means that it does not use, it does not really return anything, right? It basically uses the second argument to create some sort of result. It will write to this or do something with this response. So this is not functional. We're not going to use that. What we're going to do instead is say, I want to return a response, right? So now we have a bit more functional. We might even also make this a functional interface. Makes sense. Right? We want to use this function in combination with Java 8 lambdas. So let's give it a Java functional interface tag. So this is good enough. However, this is also supposed to be a Webflux framework, right? So I have to deal with asynchronicity. We have to deal with the fact that a response or a request might not, the response might not be available right away, and we don't want to block. So what we rather do is, instead of returning a plain response, we're going to give it, once again, a mono. So we're going to say, this function will handle the request at some point and return a server response. And that's all we need for now. So let's start using this. Let's start saying, okay, I want to, once again, those controller methods, I want to do those, but now with this particular handler function. So I'm going to need to write everything that's in these methods, this, and this, and this, in terms of these handler functions. So let's do that. I can give a couple of examples. I can say, create a handler function, and I can do it like this, right? And I can say, return server response, okay, build. All right. This is obviously anonymous in a class. You're using Java 8, so let's use lambdas. Looks a lot better this way. So this is a very simple handler function. When a request comes in, we basically want to return a 200 OK status, right? There's other statuses as well. There's accepted, bad request, not found, all these other status. There's even a way to provide a status from the status enum. So this is very simple, obviously. Let's make it a bit more complex. This is going to be my function 1. Now I want to expose a person. I'm going to say person is new person. Create self. So I'm Arjen. My age is 42 years old. And I'm going to create a handler function 2 that exposes this particular person. And here's how we do that. We basically say, I want to provide this response with a synchronous body, right? It's not asynchronous anyway, it's just a person. In a moment, I'll show you the synchronous version, but the asynchronous version, but now we're going to use the synchronous version, just exposing this as a person. That seems simple enough, right? We might even say, specify the content type here, saying, okay, rather than so now we're saying, okay, I want you to render this person as JSON. That's exactly what we're indicating. That's all possible. Once again, however, it's not very typical. We're dealing with Webflux. We're dealing with asynchronous data sources. So it's not very typical that you'll get your data in terms of a plain object. But more likely, also keeping in mind what we have in the person repository, what's much more likely is that it's going to be a mono person. So I'm going to create a mono here, which is just going to be this particular person. And now I'm going to try to expose that. So create another handler function. And that's, again, taking a request. We say server response, OK, and then body person mono. If you use this particular method, body, you'll see that you can provide a publisher, right? So that's Flux and Mono are both publishers. But you also notice that you have to provide a second argument. So here, you need to say this is actually going to be a person class. And the reason for that is that this is not a list. Remember, this is a stream of things. We have to know upfront what's going to be contained in that stream, but we cannot check ourselves from the perspective of this body method, because there might not be an element there yet, right? It might be coming later. So in a way, we are framing up this sort of response. We're saying, well, the things that you're going to have to render is a person class. And then when that person comes in from the model, we'll know exactly what to do and how to render it. That's why you need the second argument here. Okay. So these are just a couple of examples of handler functions, right? Now, let's say we want to expose this repository that we have. This is a very typical repository once again, so I want to expose this over the web. So let's get rid of all this stuff. We don't need that anymore. Instead, I'm going to say, let's create a repository. So new dummy repository. And I'm going to say, okay, handler function. Let's start with this one. Let's start with all people. That's easy. So I'm going to start a handler function, and all people is given a request. I want to say response dot okay, content type has to be JSON, and the body is going to be coming from this repository. So I'm going to say all people. Okay. So we have a function, handler function, defined here below. Given a request, return a response with the OK status, with this particular JSON content type, and then use the repository to get me all person, and once again frame it with the person class. We have to know upfront what it's going to be. So that's easy enough. We can do the same thing for the other method. So let's now try this save person. It's a bit more complex. Because now, save person, we have to take something from the request, right? We need to save something. So that person mono that we see here is obviously going to come out of the request. So I'm going to call this one get person. And I'm going to create another lambda here, where I say, I want to end up with a mono of a person. Let's call that person mono. And I want to base that on the request. So let's see what's in a request. Oh, hang on. This looks useful. Body to mono. So yeah, please give me that person. Give me the body as a person, and then using whatever marshalling techniques you have registered. Now, I'm going to use the repository to save this person. And then I have to create a response. So the obvious thing to do would be, well, the naive thing to do would say, okay, I'm done, right? It's saved, I'm done. But as I told you earlier, this method doesn't return void, it returns a mono of void. So we want to use that return type. We want to say, I only want to return the response as soon as the person has really been saved. So let's keep that result, right? Keep that mono void that we have. That's basically going to give us a completion signal at some point, and use that to build. So right here, we're going to say the response is going to be based on whenever the save operation is complete, and that save operation is dependent on the body, the request, based on a request body, which we converted to a person mono in this case. So finally, no, this is not called get person, this is obviously called save person. There you go. Finally, I want to create one for get person. person. Again, creating a little lambda here. So what we're going to do here is we want to look at the arguments. We're seeing that it needs an ID. So we need to get an ID from here somewhere. Let's try to get that as a path variable. So again, let's say integer value of, then do request path variable ID. And now I'm going to say return server response dot okay. Let's give it a particular content type. JSON. Let's also put a body in there, and that body is going to be a person I get from the repository. So repository.getPerson with the ID. And put that in the body. Okay. So simple enough. We have defined our own little handler function, which is, by the way, exactly the same, or almost the same as the one provided in Spring 5, but I just wanted to show you how it's all made up, how it's all built up. And we use that here to create 3 handler functions, right? One that exposes the repository all people, one that exposes the save operation, and one that exposes the simple getter, basically the one that does get one particular person. That said, I think there's room for a little bit of improvement here. So here, for instance, what happens if the ID is unknown, right? So we might get the particular ID for which we simply don't have the person, right? And in that case, what we want to do is return a 404 response, right? Not found. So how will we go about doing that in a reactive style, in a more functional style? So first up, I'm going to build a response that I want to send if the entry is not found. So that's very simple, right? This is my not found response. And once again, it's a mono, so it's not sent yet. It's just there if we need it, and if we need it, we're going to send it. Then I have my person mono, and instead of saying, okay, always return this, I'm going to make it a bit more interesting. I'm going to say, let's do a flat map operation on that mono. And if it's there, if I have a person, right, then I want you to return this. Okay? So if it returns, well, of course. If the person mono is there, if this mono actually contains an entry, then map this with this particular function, giving just the plain representation of that particular person. If that's not there, then I want to do something different. And that's where Mono has a really nice method called switch if empty, which we're going to use here. So I'm going to say, if it's empty, if that person mono doesn't contain anything, give me not found. And that's basically all we need. So we're saying the server response, we're going to parse the request path variable ID. We're going to use that to get a person out of a mono. We don't know up front if that person is actually going to be there, because once again, this is asynchronous code. That mono might or might not contain an entry at some point. We simply don't know yet. The only point we know is when the stream, the mono, is finished. It has given a completion signal, right? At that point, we can say, well, this stream is complete. We didn't see anything, so apparently it was empty. That's the only knowledge you have. And that's the knowledge we're using. So we're saying, use the mono. If it's there, map. If the person is there, map it to this particular response. Otherwise, switch to a non-empty response. To make it nicer, I could even inline this here. So it takes a bit less space. So this is pretty sweet, right? I mean, what I've done here is I took everything, all the code that's in the methods of the controller and exposed them with a more functional style. There's a big part missing though. Everything that's alluded to by the annotations, any kind of mapping, post mapping, get mapping, request mapping, or even on the level of the type itself, is simply not there yet. So for that, we need another element to add another element to the puzzle, and that other element is going to be called router function. So let's create our own little router function, just like we did with the handler function. So I'm going to also give this functional interface, and I have to give it a method. So the method is going to go called route. I know that for sure. And what this thing does is, given a request, I'm going to need a handler function, right? So it's an extra step of indirection, basically, saying, first I'm going to route, that will end up with a handler function, and then that handler function will be invoked. Currently, however, it looks like this thing will always return a route. And we know from that's not true, right? Sometimes a request doesn't have a match. So in that case, you want to return 4 or 4 or something. There's no handler function to handle this particular request. So once again, I think it makes sense to use a mono here to say this routing method, this router function, given a particular server request, will return or might return a mono might return a handler function at some point. It might not either. We don't know yet. Right? So it's all, once again, asynchronous. So let's use this. Right? Let's use this router function to compose or to create, to route to these handler functions. So I'm going to take a very simple, naive approach first, which is going to be a little bit naive, like I said, but it's going to be useful for you to see how all the pieces fit together. So I'm going to route this all person route here. And to do that, I'm going to create a router function, so request. And then I have to do some checks saying, well, if the request path equals my address and methods, the method is also right, the method is get, then return mono, right? Else return mono empty. I can do that also for save person. I'm going to copy and paste that in for my script, so I'm not going to type it all out. But you can see pretty much what's going on, right? We have something that will end up with a router function at some point, but there's a lot of room for improvement here. This seems, there's repetition here. This is returning empty, this is returning empty. And it seems like there's repetition here. So this obviously can be improved upon. So let's try and do that. To do that, I'm going to create a so-called utility class with router functions. And once again, this class can also be found in Spring. I'm just creating a very simple alternative to that, just to show you how all the pieces work together. And what this thing is going to do, it's actually going to be an abstract class because we don't want to instantiate it. We just want to have it contain utility methods. What it's going to do is saying, it's a static method giving me a router function, so that method route, and it will return a handler function if certain particular predicates are true. So if you ever looked in Java 8, you'll notice that in the function package is a thing called a predicate. That's also a functional interface, right? Boolean valued function, right? So it returns with a test. That seems very useful. So I'm going to use something called a request predicate coming from Spring. And let's take a look at that. Request predicate also has a test method returning a Boolean. Does this particular predicate match, yes or no, given this particular request? And then there's a way to compose them and negate them, etc. We'll look into that in a second. So this is pretty simple. Once we have this, once we have these two arguments, we can just say if the predicate. No, let's read this differently. Let's say return a new router function. In the router function itself, if the predicate matches, then return the handler function. Otherwise, return nothing, empty mono. And obviously, this can again be improved by using a lambda. So we now have a router function that says, it's very generic, saying, okay, if the predicate applies, then return this, otherwise return this. Now we can use that to refactor this code over here. So let's do that. Let's use that, for instance, on our all people's roads. So we can say, rather than doing this, it seems like a hassle, we can say router functions dot routes. Then we're going to use a predicate, so I'm going to say, well, I can actually inline it. I can say request, etc. Or looking again at the request predicates, you'll also notice that there is a link here to, or a comment here, instances of this function can able to command versus can be found in request predicates. So let's take a look there. All kinds of request predicates are useful. One that operates on methods, based on path patterns, based on headers, based on content type, all kinds of possibilities. So let's use that instead. Let's say I want to route this to this particular, using these provided request predicates. I'm going to import those, all of them, with the static import statement. And then I'm going to say path person and method get. And provide that with the handler function. Okay. So what we've done now is create a router function that routes to all people when the path is this person and the method is that. This is a very common pattern, of course, right? You'll see that quite a lot. So much, in fact, that we have one that actually combines the two. So we have this one called get, and that combines the methods into. So you can basically go there and see that it's what get does, it returns the method predicates combined with the path predicates. Very simple. So composing predicates together is something that we do a lot, and I also expect our users will do a lot, is to get the predicates that you want and need. So this is pretty simple. I can do the same thing. Let's do it below so you can compare the two. Let's say router function for say person route or two. Let's use our newly introduced function that's route for that. So I'm going to say post. If it's post to person and the content type is JSON, then I want you to return say person. Okay. So these two do the same. Right? Here we're just using a more generic version of it, one that uses predicates. but the essential algorithm is still the same, right? Testing properties on a request, returning a particular handler function. We do the same here. Testing properties on a request, is it a post to a person, and is the content type this? Then return that. So this can be removed. And instead, we can use that one. Let's create one final router function for the get person route. Router functions routes, and that one needs get as well person e, and then say. So this is pretty sweet again, right? Quite nice, but we still have 3 routes. What we want to do is combine those. We want to say, well, my website, my web application has to expose all these routes, not just one of them. I want to compose them. So you might say, let's keep a list of those and we'll just try the list in order. But that wouldn't really be the functional thing to do. The functional thing to do is saying, well, let's introduce a composition operation, a logical AND between these mappings, basically. So we want to compose a new route that is basically the combination of all these routes. And for that, we need to add a method to router function. So let's do that. I want to create a default method, otherwise it wouldn't be a functional interface anymore. So a default method, router function, let's call this method and another router function as a combination. And what we want to do here is saying, okay, return a router function, that's another lambda. Let's basically try this route first, right? We're calling this, effectively. But once again, if it's empty, there's nothing in there, let's try the other one. Very simple. Okay? So now we have a way to combine routes. We can say one route is basically a combination of 2 things, and if one doesn't match, then switch over to the other one. So let's use that over here. We want to say router function, all routes, and that's just going to be all people route and say person route and get person route. So now we have one route that we can actually execute. This basically contains all the logic that we need to want to match, and that's also all the metadata that's provided in the controllers or the annotations. Typically, if you're looking at the controller, you'll see very similar elements. Person, right? The consumes JSON. That's expressed here. We say that the content type has to be this. Okay. Let's clean it up a little bit, though. Let's create a class for this. So I'm going to create a very simple handler class that's going to contain all of the methods that I have provided for. This is not very readable, right? It's all these inline methods of handler functions. That's not how you would typically use it. What you would like to do is combine these handlers into a function, right? Normally, or so far, we've seen a controller, but there's no, we want to do something similar. We want to combine these handler methods, handler functions into a class. So to do that, we're creating this little handler class. We don't need to annotate it at all at this point in time, so let's just keep it simple. So it needs a repository to work, and then it obviously needs a constructor for that repository, and it needs the handler methods. So I'm going to start with writing one out, and the rest I'm going to copy paste over. So we need to follow the handler methods, the handler function signature in our, right? So we need to give a request, return a mono server response. So that's what we're going to do, give a mono response. Let's call this all people server request. And what that will do is essentially this. Copy that, put that image. Okay. Right, so we just taken the function and moved it into a class, more or less. And I'm going to copy over the other ones because I don't feel like typing all of this out, but you can assume that these are all the same, right? So we have and we have this as well. So we now have a nice little handler class that represents all of our handling code in one. Let's try to use that instead of using the regular methods that we put, or the inline handler function that we've done so far. Let's use the handler instead. So let's use my person handler. New. It needs the repository to work, and then this can all go because that's in the person handler now, right? That's all gone. Rid of that. And I want to say this is going to be, instead of all persons, it's going to be handler. Sorry, person handler. All people. So I'm using Java 8 feature called method references to basically refer to a method of an instance. And Java is going to conform that, make that into a lambda, basically, this particular method. So this is a nice way to share or to organize your handler functions into related classes rather than putting them all in line, doing it all together. This is a much nicer way to do that. So let's also do that for save person handler, and also for person. Okay. And by this point, we might actually also inline these as well, right? There's no need for keep all these routes around. The only thing we're interested in is the complete puzzle. So inline this. Inline this. Finally, inline this. Then with another little static import, it actually looks quite nice. So, by this point, I've shown you basically pretty much what the functional framework, how it's made, how the pieces work together. You have handler function, you have router function, you have request predicates. I've used very simple versions of these, not to overwhelm you. So by now, I'm going to switch over to the real deal. So I'm going to remove all of this. And I'm going to also remove the handler here, because I actually have a handler I created earlier, so I'm going to use that instead of my inline class. So let's do it like this. And then I'm going to say this can go. I'm going to use the router function as provided by Spring 5 itself, and not my little experiment one. This one is actually generic, so you have to provide it with a particular type. And the route method, I can statically import that, and everything works as expected. So I switched to using actual Spring 5 instead of my little toy framework. And the reason I do that is because there's still room for improvement. We have extra data here. We have person, and person here. That's repetition. We don't want that. If you look at the controller, you'll see that we fixed that by having a type level annotation, and this type level will be applied to all of these underlying methods. We want to do something similar with the functional framework, and we can do that with a feature called nesting. So I'm going to nest some routes. And the way you do that is, once again, if you look in the Java doc of nest, it says, this method can be used to create a nested routes where a group of routes share a common path, prefix, header, or other request predicates. So I can basically say, I want to share some feature with these routes. So I'm going to say, for all of these routes, I want the path to be /person. right? And then this route doesn't need to get anymore, doesn't need this path anymore because it's already provided here. So instead, we're going to say this. It needs the method get. Same here, right? This is the same as there. It's already nested. It's already provided. So I don't need to give that path again. I can just nest this. No, method has to be post, obviously. Okay. And then finally, same thing applies for here, except that here we do want to add a bit extra path. We need the ID. So I'm going to use that one instead. So this is nesting, where we say, I want to share this particular route, right, this particular predicate, among all the routes that I provide later. Well, actually, it's just one route. It just happens to be a route that's composed of others. Okay? Very useful feature as well, not just for path, but also for other kinds of variants. So right now, I'm going to switch over to a version of this demo that I prepared earlier. And that's actually given right here, since we're getting close on time. So I want to show you this thing actually working, not just me typing code. So what we have here is a little server class with a host and a port. What we need in order for this to work is a handler function, right? Oh, sorry, a router function. I actually have two ways configured here to do that. There's basically a standalone mode where you just do everything yourself, like you do here, right? I saw earlier, repository, handler, and then we create our routes. You can actually see here that we have a doubly nested one. First we nest with the path, and then I nest for JSON. So, okay, this nesting only applies to these two routes in here. Well, this applies to all three. We convert that into an HTTP handler that can be executed in Servlet 3.1. So that means Tomcat, Undertow, but also reactive runtimes like React and Netty. So let's run this thing, and I'm going to run it the application context mode, and I'm going to run it in reactive. So here's my configuration class. I just added an enable web flux, and the only thing I'm doing here is exposing my router function as a bean. I have my repository wired up, I have my handler wired up. So let's start this up and see what it does. Right, that seems to be working. So let's see if it accepts some requests in the README. I'll provide the link to this code later when we get to the Q&A part, but for now, here are some curl commands that I will use to test this thing. So let's see if I can get to terminal. Here we go, doing a curl on the localhost person. You can see here in the bottom that I'm getting the two entries that are provided in my dummy implementation. Right? There we go. If I add another one by posting, I have to use this command. So I'm using curl -d, yada, yada, yada. So let's try that. Oops, let's copy that first. Copy, paste. I get a 200 OK, so everything went right, I guess. And let's do the all again. So, and then we see the person I uploaded is now also present. I can get individual entries like so. This is the get person route we're executing, right? So person number 1, oops, person number 2. But if I enter a number in there which is not present, you also see the 404. Right? So that's pretty much, I think, all we have time for. Maybe some time for questions, but I'm going to switch over to my slide deck again. And I'm going to show you where you can find some additional resources. The slide deck, by the way, contains much more information than this, so you can take a look at that. So here, in the meantime, are some things for you to look at while I wonder if there's any questions, Peter.
Yep. And folks, this is a good time to look at the attachments and links section of your user interface. In fact, the link to the slides that Arjen was just mentioning is right there, as well as some other resources. So this is a good time to check that part of your user interface, because when the webinar ends in 5 minutes, obviously those links go away and are no longer clickable. So yeah, there were a couple questions. One of them was very specific, and I didn't quite catch which line of code it was about, but it was asking, would the this was sort of a quick technical one. People were curious if the code is in GitHub, and I think the answer to that is yes. Yes. Is there a link in the presentation to that, perhaps?
Yes, you're looking at it right now.
Fabulous. Okay, thank you much. Yep.
The
yeah,
first
I see
link.
that. Okay, very good. I'm still
it needs,
seeing the
we
screen.
just released RC2, by the way, today, so it might need some change. I haven't really had a chance to update that. I'll do that later this week, but so it might run a bit behind the code that I showed today, but it will be updated soon.
No problem. Okay, cool. Yeah, so the folks, if you want to get the replay of the webinar, there's an announcement that's displaying on the screen right now. You can just go to content.pivotal.io webinars. In about within 24 hours, you'll see the webinar show up as one of the sort of consumable tiles of content there. You can click on that and it'll have attachments and links to things on the website, like the GitHub repo and stuff. So we're going to end in about 2 minutes here, so we got to wrap this up super quick. I think we're only going to have time for I think we actually might not have time for any questions at this point if we're ending in 2 minutes.
Oh, that's a shame.
Yeah,
I'll try and answer questions offline if that's necessary. So if you have any questions, feel free to ping me on Twitter or leave a question. If you let a question, then we'll find a way to answer those questions later.
We have a way to answer them. Anyone that's entering in questions, we're going to respond in text, and that will be posted as an attachment to the webinar replay. So please take this time to lob in your questions now. And we will get to them asynchronously, which is strikingly appropriate for this particular webinar. So yeah, and then folks, you're welcome to come back and join us on, let's see, we're going to have another reactive webinar on next month. So you're welcome to come back and join us for that. Hopefully you've gotten the URL for the replay of this one. And if you'd like to come back and join us, there's going to be a talk on full stack reactive at NoSQL with Spring Data and Couchbase, which should be pretty cool. Matt and Grethanon is going to be presenting that. Former manager, one of the Spring team members, Simon Basley, as a matter of fact. So yeah, so please type in your questions. Arjen, thank you so much for your time and bringing this new framework to everyone's attention. Is there anything you want to say to wrap up?
Yeah, I want to give an extra point or two. If you're into Kotlin, which seems to be getting more and more popular these days, there's actually a Kotlin version of this as well, which uses Kotlin's language features